Greetings, detectives. Mrs. McKay here, and we are on our very last clue of our last case of the school year. So this is 7-3, case 3, and this learning target is pretty simple. So hopefully, as long as you remember what we've learned about exponential functions, we should be able to get through this pretty quickly. So let's start by filling in our learning target clue. I can recognize, so write the word recognize, and represent, this should be two words, vertical, so you're going to write it small, vertical translation. Vertical translation of a function, all right? I can recognize and represent a vertical translation of a function. Now, before we go any further, we've already done some vertical translations of linear functions, and we saw that as we added or subtracted from the constant in y equals mx plus b, the y-intercept, that in essence, our function moved up or down. It was the exact same slope. The line was the same slope. It just moved up and down the coordinate plane based on where the line crossed the y-axis. So now let's talk a little bit. Let's go back and review what we learned about exponential functions. So if you remember, an exponential function has a graph that looks something like this. Okay? It usually has a rapid increase or a rapid decrease. So another way to look at it would be to look like this, to go kind of like this. Okay? So that's a rapid increase. So that's important to remember. The other thing that's important to remember is the actual equation that we used, which was, I think I'll use f of x. Oops. All right. F of x equals a, okay, to the, and we usually had a constant, and I don't remember what letter we used for that. Just the letter B, to the x power. So sometimes it was just f of x equals b to the x power, but sometimes we had a starting place, and that's what our a was the starting place. So those are two things that are important to remember about exponential functions. Now, let's see if we can figure out what this exponential function is. And if you look here, right here where it says finding the constant ratio, what I'm looking for is I'm looking for this b, which was the constant ratio. And then we multiply that constant ratio by itself to the power of whatever our x was. And then this a was kind of where we started. Okay? So let's take a look at this graph right here. We have x equals 0 and f of x equals 5. X equals 1 and f of x equals 10. X equals 2, f of x equals 20. X equals 3, f of x equals 40. X equals 4, f of x equals 80. Can you tell me what the constant ratio is? What are we doing to get from 5 to 10, 10 to 20, 20 to 40, 40 to 80? That's right, we're multiplying by 2 each time. We multiply by 2. So our constant ratio is 2. So if I was going to write this as an equation, I would say f of x is equal to 2 to the power of x, because each time I multiplied by x, or I had my power be x. But there's more to this, because if I just said f of x equals 2 to the power of x, then if I said f of x is 0, then 2 to the power of 0 is 1, but here it says 0, when x is 0, f of x is 5. So what is going to be my starting point? What is going to be my starting point? I need an a to go in front of this 2 to the x power. Well, you're right, it's 5. So we start with 5, because when x is 0, this would be 2 to the 0 power, would be 1. 5 times 1 is 5. When x is 1, 2 to the 1 power is 2, and so 5 times 2 is 10. When x is 2, 2 to the second power is 4. 5 times 4 is 20, and you can see that we've got our pattern set up. So that was just a quick reminder of finding constant ratios and understanding exponential functions. Now, if I wanted to graph this, I'd say when x is 0, I'm going to make each one of these be powers of, or each one of these be 5. Okay, 5, 10, 15, 20. Okay, so when x is 0, f of x is 5. I'm going to let these be 1s just because I want to be able to see my graph. So this is 5, this is 10, all right? And when x is 1, y is 10, or f of x is 10. When x is 2, y is 20. When x is 3, we got to get up to 40, 5, 10, 15, 20, 25, 30, 35, 40, and you can see that I'm starting this rapid increase all the way up, right? Okay, so now let's look at a real world problem. Here's Rebecca. Rebecca owns a house, and when she bought her house at 0 years, the value of her house was $150,000. So this is Rebecca's property value right here. After a year, her property value went up to $159,000. After 2 years, $168,540. After 3 years, $178,652. And after 4 years, $189,372. Now, don't worry. I'm not going to ask you to tell me what the constant ratio is. I'm going to tell you that the constant ratio is 6%. That means that every year, Rebecca's value of her home goes up by 6%. And I'm even going to tell you that the property value in relationship to time is $150,000, which was her starting rate, times, let's put this like that, 1.06, that should be a t, 1.06 to the t power. So every single time we multiply this, her amount, by 1 and 6% each, and it's to the power of whatever t is, the time. Okay, so that represents the value of her home. So if I wanted to find out how much her home was worth after 5 years, I would take $189,372 and multiply it by 1.06 to the 5th power, because basically I'm taking 6% of 189,372, taking 6% of that, and I'm adding it to the already 189,372. So that's what that 1.06 is. And because I multiplied by 0.06 5 times, that's why it would be the 5th year. All right. Now, Jeremy says that his home is always worth $20,000 more than Rebecca's. It's just the way it is. Where his home is, it's always worth $20,000 more. So here's the value of Jeremy's home. At 0 years, it's 170,000. At 1 year, 179,000. 2 years, 188,540. At 3 years, 198,652. And at 4 years, 209,372. Now, here's what I want you to do. I want you to see if you can figure out what the common ratio is between the years for Jeremy's home. See if you can figure out what the common ratio is between the years. I think you're going to find it's a little tricky, but start by seeing if it's similar to Rebecca's. If we take 6% of 170,000, if we take 6% of 170,000, so go ahead and figure out what 6% of 170,000 is. So when you take 170,000, and I hope you used a calculator, and you multiply it times, I'm going to multiply it by 1.06 so that I don't have to add it to the 170. I'm just going to figure out what 170,000 is plus the 6%. I get 180,200. Well, that means that in year one, from year one, Jeremy's home did not go up by 6%. Because 6% would have been 180,000. Well, what could that be? Let's see. Now I could do some work and I could figure out, I could take my 170,000 and divide it by 179,000 to see if I could get my percentage. It looks like my percentage is 94% or 95%. So if that would mean that this went up 5%, if I added 5% of 170. So let me try that. So if I take 170,000 and I multiply it by 1.005, I get about 178. It's because I didn't round it up. So let's say, but what happens if I take 179 and I multiply it by 5%? Am I going to get close to 188? Let me look. 188,540 times 1.05 equals 5% of 179 is 197. So it looks like my percentages are going down. So this does not have a constant ratio. It does not have a constant ratio. Jeremy's home does not have a constant ratio. So what could we do to represent Jeremy's home? Well, the function for Jeremy's home is a vertical translation. That means Jeremy's home, so I'm going to write J of t is equal to, Rebecca's was P of t, and actually it would be smarter if we said R of t, but that's okay. So Jeremy's home is actually Rebecca's home, which is P of t plus 20,000. Because every time whatever Rebecca's is, it's just adding 20,000 to it. So it's not, Jeremy's home is basically a vertical translation. So if P of t is 150,000 times 1.06 to the t power, then I just have to take whatever that is and add 20,000. And that's what Jeremy's property value is, okay? It's equal to Rebecca's, which is 150,000 times 1.06 to the t power, and we add 20,000 to it, okay? So one thing that I want you to notice is I want you to notice that a vertical translation always adds a constant to a previous, to the pre-image or to the previous function. So this up here, g of x equals f of x plus k, is the formula or the way that we represent vertical translations of functions. So regardless of whatever the function is, if we want to find a vertical translation, so this would be g of x would be the vertical translation equals f of x, which is the original function, plus k, which is the constant. That's important. You need to be able to recognize that, okay? The function doesn't change, it just shifts, it translates. So the translation, g of x, is equal to the original function, whatever that original function looks like, and all we've done is we've shifted it up or down in a vertical direction by a constant, okay? Now, let's try some. Here we have a function, and we're going to write the function for f of x. We're going to write it for g of x. Change that to g of x. We're going to write the function for g of x. We're going to graph both functions, and we're also going to show the table of values. So here's our function. If f of x equals 3 times 2 to the x power, and g of x is f of x minus 5, then what would g of x be? What would g of x be? Well, g of x would be whatever f of x is, which is 3 times 2 to the x power minus 5. I need to make this a little bit even skinnier. Okay, so that's what g of x is. 3 times 2 to the x power, that's an x, minus 5. So let's fill in a few tables of value. Let's start by saying, what if x is 0? Well, if x is 0, what's f of x? Well, f of x is 3 times 2 to the 0 power. 2 to the 0 power is 1, so 3 times 1 is 3. All right? What about if x is 1? If x is 1, 3 times 2 to the 1 power, 2 to the first power is 2. 3 times 2 is 6. You figure out what f of x would be for, whoops, that should be a 2, for 2 and 3. So what did you come up with for 2? You should have come up with 3 times 2 to the second power. 2 to the second power is 4. 4 times 3 is 12. And what did you come up with for 3? You should have come up with, you might have noticed now that the constant ratio is 2, so we're just doubling this. We're doubling the next one, but 2 to the third power is 2 times 2 times 2 is 8. 8 times 3 is 24. Now, let's do g of x. G of x is just f of x minus 5. F of x minus 5. So what would g of x be when x is 0? Well, 3 minus 5 is negative 2. And what would it be for 1? When x is 1, g of x would be, that's right, 1, because 6 minus 5 is 1. And what would it be when x is 2? 12 minus 5 is 7. And for 24, or when x is 3, 24 minus 5 is 19. All right, so we've just filled in our tables. Now let's graph it, shall we? Let's try graphing it. So we're going to start, I think I'll use a different color. We'll start by graphing f of x. So let's graph f of x. When x is 0, f of x is 3. So I don't know if I want, I think I'm going to make these be 2, 4, 6, just so that we have a little bit of space, all right? And we'll just make these be 1, 2, 3, all right? So 1, so I'm just changing my scale a little bit. So when x is 0, f of x is 3, so right about there. And when x is 1, f of x is 6. When x is 3, f of x is 12, so 8, 10, 12. And I don't think I can get 24 in there, but let's try it. When x is 4, let's see, this would be 12, 14, 16, 18, 20, 22, 24, way up there. All right? So here's my function, and I'm going to try to just kind of draw it out a little bit. We're going to say this is a continuous function. It's terrible, sorry. Okay, you're much better at drawing than I am, so hopefully you did a better job than me. So there's my f of x, so I'm going to label that f of x. Now, let's graph g of x. Let's do it in green or blue. All right, so when x is 0, f of x is -2. So that would be right there. All right? And when x is 1, then f of x is 6. When x is 2, f of x is 12, which was this one. No. Oh my goodness, it's not 6. When x is 1, f of x is 1. Sorry. So it's right here. There we go. Get my graphing right. Ignore that right there. That should be, we'll make that one be pink so that you can see it, because I was looking at the wrong graph, or the wrong value on the table. So when x is 0, g of x is -2. When x is 1, g of x is 1. When x is 2, g of x is 7. So right about there. Back to blue. When x is 3, g of x is 19. So let's see, we've got 8, 10, 12, 14, 16, 18, 20. So we go down 1 to right there. Right about there. So you can see that my function is following a very similar path. G of x is following a very similar path as f of x. It's just shifted. It shifted down. Okay? It went down 5 spots. All right? So that's really all you need to know, is you need to be able to recognize and perhaps represent a function. If you looked at this function and you said, let's make this be g of x. What happened to g of x compared to f of x? Well, it's f of x minus 5. And you could really just look at where it crosses the x-axis, or just pick any common points, find f of 2, and then look at f and g of 2 and see how it shifted down. All right? Now, let's do a little bit more practice over here. So, here we have, we're going to say this is f of x right here. F of x. So there's f of x. Now, this right here is f of x, and I want you to find g of x. G of x is f of x minus 3. So tell me, what would we do to sketch g of x in here? What would we need to do? Tell me what we would need to do. Well, we're going to take each point and we're going to shift it down 3. So I'm just going to pick some points. I'm going to pick this point. I'm going to pick this point, this point, this point, okay? And I'm going to shift it down 3. It's going to be whatever f of x is minus 3. So let me actually give some little marks. You should do this too. All right, so I'm going to take this point right here and I'm going to shift it down 3. 1, 2, 1, 2, 3. And then I'm going to take this one and shift it down 3. 1, 2, 3. And I'm going to take this one and shift it down 3. 1, 2, 3. And you can see that my function g of x is just a vertical translation, all right? So I've just shifted it down. So this is g of x. Now, let's look at this one. Now this is called a quadratic function. It's a parabola. We haven't studied it yet, but that's okay. We can still do vertical translations. So if this is f of x, if the graph that we're looking at is f of x, and we want to graph g of x, tell me what are we going to need to do to sketch g of x if g of x is f of x plus 2. What are we going to need to do? That's correct. We are going to need to shift this entire function up by 2. So I'm going to go ahead and mark this here. And like this, okay? So I've got, let's do 1, 2, 3. Now we've got stuff on the negative side over here. The cool thing about quadratic functions is that they are symmetrical, and so they are reflections. They have a reflection, a line of reflection. We call it an axis of symmetry. But let's start by just picking this point, which is nice and simple. We'll do this point. We'll do this point, and this point, and maybe this point, and this point. All right, so we're going to shift those points up by 2. So we'll start here. We'll go 1, 2, and this one will go 1, 2, and this one would go 1, 2. This one goes up 2. Notice that my x values are staying the same. The only thing that's changing is it's shifting up. So we've got this. It's going to look something like that. Okay, exact same function, just shifted up. It's going to end up having the same width. Like we could take this and move it and lay it on top of here. It would kind of line up exactly on that parabola. It's just been shifted up. Okay? That's it. That's shifty functions. And the key I would say that you want to remember is this right here. You want to make sure you know that. G of x is equal to f of x plus k, where k represents the constant. All right, that's it, and we are done. I will see you in class.